Invoice extraction bot. We'll be implementing this particular application using Langchain and an LLM, which can be OpenAI or Llama 2. Right here, I'll just walk you through the working of this particular application. It is asking for some files to be uploaded. We can browse them by clicking on this particular button right here. You can select any of this. Let me select all of this and click on that. Once this is done, we can click on the button right here which says extract data. So this is running right now. Once this is done, we should be able to see the results, which is a table containing all the extracted data like this: the invoice number, description, quantity, date, unit price, and all these things, along with the phone number and address. And you can also download the CSV file. Yeah, this is how the file will look like with all the values being extracted. Let's go ahead and try to implement this. Let's try to go ahead and implement the application that we have just now saw. The first step for that would be to implement the files. Let's keep it as app.py. Here we will implement the front end of the application, and for the back end, let's use another file called utils.py. And as we know, we will be communicating with the LLMs and different services going forward. We'll create a dot environment file and dot environment example file so that we can store all those particular credentials. As I already have them, let me paste it right here. This is there. Let me go back to this. As you can see, we have the values available in this particular file. The schema of this will be available in .env.example file. We'll be using two services here. One is OpenAI and the other one replicate.ai. This I'll soon let you know, as you're already aware of this, so I'm not going into this particular thing. This I'll just explain it to you as we go towards the implementation. Let's concentrate on the UI of the application. This is the code that we will need for the implementation of the UI. I'll walk you through each one of this. Please make sure that you have selected the appropriate environment. For me, this is 3.10.8 64-bit. I'm saving this. Let me go to the terminal and run the app. Streamlit run app.py. Then run it. Make sure that you have all the dependencies that you need. This is how the UI will look like. This is the header and this is the part where you'll be uploading the documents. And as soon as we click on this, you should have a response, the original response. But here we have a hard-coded value for now. This is how we were able to build the UI of it, as this indicates the title of the page and this the title of the body and then a subheader. We are able to get all these things from Streamlit library. We have a component by using which we can take the inputs from the user, which are PDF files, st.file uploader, and then the type of this should be PDF, and it is giving the access to select multiple files. Once this is done, we'll click on the extract data button. If this is clicked, that is what we have right here. We are using st.spinner, which actually gives a waiting progress kind of option on the screen till this particular part of code is being executed. And once this is executed, we will have a success case, as you can see this one. And here we are invoking the main function because we want this to be executed whenever this itself is being executed as a project, rather than this particular app.py being used as a module. This is done. This will load all the keys available right here into the environment. That's it. So we'll go ahead and try to implement the backend logic of this particular application. We have already seen how to run the Llama 2 model locally on your CPU. We'll also have a look at replicate service, which is a kind of hosting which will help you host your ML models and try to use this for your prediction. And there is some pricing associated with it. These are few of these options. You can host your own model and then use it as an API. Because Llama model needs a lot of infrastructure for it to run. Most of the use cases that we see over YouTube or anywhere else are on Google Colab. So I tried to replicate the same thing in replicate.com by using this service. Few of this initial predictions that you will actually use up will be free. If I just go to this, right, they have already told that this will cost some money, but few of your initial calls will be free. Okay, that free version should be more than enough for you to at least experiment with this platform. You can also use different AWS, SageMaker and all this particular platforms, but for this we will limit our experimentation to replicate platform. I'll be going ahead and using the models that are already available right here, which is Llama 270 billion chart. I know this will consume a lot of infrastructure, so we'll just experiment with this model in our project. If you're interested, please go ahead, read the documentation and try to upload your own model and then experiment with it. Let's go ahead with the implementation. Let's move on to the backend implementation of the code, which is utils.py. Here, I'll just try to paste all the code and the functions that I have with me, and I'll try to give a good walkthrough of this all functions. Moving to the top, you have to import Langchain, PyPDF, Pandas library, replicate, and all these things for this whole code to work. Please go ahead and do it if you don't have this installed on your system. Once this is done, then we can just import them and their respective modules. First thing that we will try to do when we have an application like this is, I just close this extra tab. We'll try to upload the files and then we'll try to extract the data out of it. For that particular task, we need a data extractor. This is what we are doing with this function. Extract information from PDF files. This is the function right here. I've given the name of get PDF text. It just takes up a file which can be something that we have uploaded, the invoice itself. Let me copy the invoices into the current project that we have. Once we click on this, this is how the invoice will look like. It has the bill to address, company's name, invoice number, date, description of the item, the quantity, unit price, amount and total. These are some of the fields that we will try to extract from this PDF. Going back to this and then this is what will be passed on to this. From here, we are just initializing a text variable with empty string. And then by using this library that we have just now imported, we will use this module, which is taking up the file of that particular PDF. And then from each page available in that particular PDF, we'll try to read it and append that particular text to text variable that we have. And then it just returns it back. This is what this function is doing right now. This has a very simple task assigned to it. Then comes extracted data. What is this exactly? Once we have the data with us, we need an LLM, large language model, to give this particular output, which is the invoice data, right? For that, we will need some intelligence, which can be OpenAI, Llama 2, Hugging Face models, or anything. So this function will help us with exactly that. It is taking up the data that is coming from the PDF page, which is the output of this particular function, and then we have a template written which says extract all the following values. What are the values? Invoice number, description, quantity, date. All these things are coming from the PDF that we have just now seen. These things exactly. We are advising the large language model to do that particular thing. Once we have told all these things, we are also giving the context from where it has to pick these values, which would be this data. And then the expected output we are defining. Please remove any dollar symbols because this sometimes causes issues. And this should be the format of this. This is what we are giving an example of how exactly the output should look like. Once this is done, we have the prompt template module which we can use, which is coming from the Langchain. It takes up the input variables, which is the data. This thing resembles this placeholder right here in the template variable. And here the template represents this whole template into which this variable is going into. Once we have the prompt template available, we can either use OpenAI as the LLM for us, which can be an intelligence which will be used to extract the data out of the invoices, and also use the LLM model and then use this LLM model to extract the invoices by supplying the data coming from the PDF file to this particular template. Please refer to the earlier videos that I have uploaded, which will exactly explain you how this prompt template works. This is one part of it. This is something that you might have already implemented or you're aware of. But then we have another code which is available here, which helps us use the Llama 2 model, which has been released recently. This thing I have already shown you how you can use it locally. But right now I'm going ahead and trying to use a technique where we will be hosting our model, which is Llama 2 model, on a ML hosting service, and then through the API we'll be accessing the prediction coming out of that particular web service. Let me show you how exactly this works. As it says, the below code will be used when we want to use Llama 2 model. We will use replicate for hosting our model. As you can see, replicate.com gives us the ability to host our ML models, which can later on be used in production ready applications. Here I have chosen this for this particular project. There are a lot of different services available which you can opt for. I've tried to experiment a little with replicate services. So there are a lot of models that are already available, and one among this is Llama 2 70 billion chart. This is what we'll be using. As you can see, 70 billion parameter language from this is used for chart completions. You can also go ahead and try to learn through documentation, where you'll be able to push your own model to the replicate and try running your application on top of it. There are different steps right here which you can go through and upload your own model to the portal. Back to this, there's a demo right here which says this is the input prompt that we are giving, and this is the system prompt, which is just an instruction to the LLM. And then there are few of these parameters: max new token, maximum number of tokens to generate. A word is generally 2 to 3 tokens. And then the temperature, top k values, top p values, and repetition penalty, and all these things. You can go through the description of this to understand it better. And once we are passing all these things to this repository, we'll be able to get the output like this by clicking this submit button right here. And there are a few of these instructions available right here, which says this model cost approximately this to run on replicate, but this varies on the input that you're actually passing on. And this will be using NVIDIA 880 GB GPU hardware, which costs around this per second. And as you can see, a typical prediction takes this much time. So please consider different alternatives available in the market like AWS, SageMaker, and all these things. You can also look at the pricings of this. If your model uses CPU, then the charges for that would be this. For us, it is charging this particular infrastructure for us. It can change based on your model. Coming back to this, we'll be going ahead and using this model as our intelligence, which would be the LLM. To use this, we have few instructions written right here under API section. This code can be used for that. We will be using this model for now, though we don't need 70 billion. Rather, we can go ahead and use Llama 2 7 billion chart for us, but that is not there in this particular portal for now. So I'll just use up this thing. I can't find it here. So I'm just going ahead and just for the experimentation, I'll be using this particular model. I know it will cost a lot for me rather compared to 7 billion chart model, which is this model that we are talking about. We are using this model for now, but this would be more than enough for our experimentation. Though, going back to the code, here as you can see, I'll just comment this out. and then enable this code right here. I'm using control// for this. This is a comment, so let me comment it. Yeah. So here, for this to work, we have to install the replicate library and import it into the file that we are currently working on. Once this is done, on this particular class, we are trying to run a function called run, which is taking up few of these parameters. The model address, which is coming from this particular page in API tab, you will have something like this. This is what you have to copy and paste it into your code. Once this is done, it is expecting another parameter called input, into which you have to pass your prompt, which is this whole thing, which includes the PDF data also. And there are few other parameters that you can fine tune your model with: temperature, top p values, max length, repetition penalty, and all these things. Once you have all of them, you have to form your final response, because this generates a generator object type. To get the whole information out of it, we'll be using this code right here. For each item in this particular thing, we are concatenating it to form a complete string. This is what we are returning back. Awesome. We have this understanding clear, I guess so. Once we have this, moving back to this, we have the final thing, which is iterate over files in that user uploaded PDF files one by one. There is a main function that we will try to call from right here, because once we have the PDF files from the user, next we'll try to pass them into this function, which is create docs. Here we'll just take up all these things, the files list, and then creating a data frame with necessary column names. As you have seen in the application that we have created, we have a tabular structure which is displaying the extracted information of the invoices. For that, we'll definitely need a data frame. That's where we are trying to create a data frame with specified column names and their data types. This is one thing. And then because we have the PDF list right here, which is coming from the user, we are using a for each loop to get each file and do or perform some actions that we actually need. First thing, just to confirm if we are able to get that particular file, I'm printing it right here. Once we have this, then we are using get PDF text function. Looks like we have seen it somewhere. This is the one. We are using this function to get all the information being extracted from that particular PDF file. Once we have this, we are assigning it to a variable called raw data. You can also have a look at it while running the code by using print raw data, and then you can also have a print statement stating this is done. Then comes extracted data. What is the use of having the raw data with us? The main agenda here is to extract the information from the PDF. That is what we are trying to do by using extracted data function. As we have already seen, this takes up the data from the PDF, the raw data, and uses an intelligence, which could be Llama 2 model or OpenAI model, and then gives us the output. This output is something that we can use up, right? Yeah. So that's where we have the LLM extracted data being stored into this variable. But the problem here is the data coming from the LLM will have some extra data in it. We'll have a look at it. I'll just uncomment this for you to understand it better when we run this particular function. Because we are expecting some junk data coming along with whatever is expected, which is this format, we have to perform some text processing to clear up all that unnecessary data. So this is what I'm writing here, which is using a regular expression. Here we are defining the pattern for the regular expression, saying anything that comes between this flower bracket should be considered. Please search it with this pattern into this particular LLM extracted data. This gives us the match. If there is a match, we are going into this. If there is no match, we are saying no match found. This is what we are doing right here, capturing just the required data and excluding any unwanted text. This should be text from the LLM response. Once we have this, obviously we know that we want to display it on the screen. For that, we have to append all this data that is coming up from the LLM to the data frame that we have. Here, To this data frame that we have created, for each loop, we are appending some data, which is the data dictionary, which is nothing but this, after applying the regular expressions and all that. And then I have kept a print just to understand if each one is being executed or not. Once this is done, we are returning the whole df, the data frame that we have right here, to the app.py. So that is what we have to implement here. To do so, I am just pasting the code that I already have with me here. As you can see, we are trying to call the create docs, which is coming from this one, but it is giving an error because we have to import that module from utils, import everything. Let's save this, and this is gone. We are calling this function which is doing all this tasks of extracting the data, then using LLM to extract the entities and then formatting them, then adding it to the data frame. This data frame is being retrieved and being stored into this particular file. Then we are using st.write df.head to display it on the screen. This is one part of it. And then we want the user to have an option of downloading the extracted data. This is where we are using df.toCSV function, which will actually convert this to CSV format. Once we have this, we are using st.download button component that comes from the Streamlit to give a download option to the user. The file name of this would be invoice extracted data, and then we are saying download data as CSV, the option of that particular button, the label of that particular button. Here it should be C here. Yeah. So this option would help us download the file as CSV. This is all done. Another thing that I want to highlight here is, as I was using this particular service for my application, it was billing me, and the bill I can just show you right here. It is still loading. I have kept a limit of $5 right here, and it has costed me around $3.4 for this particular application or the experimentation. This is quite huge because I'm using the top model of this Llama 2, which is 70 billion parameter model. If I might be using this, it would have costed me less. I've actually added my credit card here for the experimentation, but most of my initial calls were free, so you can just utilize that to at least understand or get started with the Llama model. Coming back to this, as we know that we are already ready with our implementation, everything is there. We have kept a print statement here, and this is the raw data. Let me print that too so that you understand what exactly is happening. And yeah, this should be more than fine. Let's try to go ahead and run this particular application that we have just now implemented. Streamlit run app.py. Yeah, the application is ready. Let's go ahead and try to browse some of these files. These are the files. I'm selecting all of them and clicking on open. This all are loaded right here. Let me click on extract data. Will take up some time. Let's go back to the code. As you can see, it has extracted the data from the first file. This is the raw data right here. The LLM is currently working on top of it to get the data extracted. This is the data that is being extracted from that, and then this is being pushed to the data frame. This is the second file, and this is the raw data. The LLM is working on top of it. Looks like that is also done right here. This is something that you can see right here is LLM extracted data after applying some text processing. This is also done. Let's go back to the application once. We have the results ready. So there are 3 files that we have uploaded, and we have got the results for them, and we are also having an option to download the result. If I just click on this, it should be able to do the same thing for me. Here is the data. So based on your requirement, you can just uncomment this OpenAI and have that key right here. If you are interested to use the Llama 2 using replicate service, you can just use this up. It's completely based on you. I'm just commenting out this for now and enabling this so that for the initial runs, you can start using OpenAI as your LLM just to save some cost. This is completed. Hope you have learned a good amount of knowledge through this particular experimentation. Stay tuned. I'll be posting more such projects based on this LLMs that are coming up in the market.